Hey, it's Mrs. Weefy, and we're going to continue with Lesson 3, Part 2, the periodic trends. Now, in a previous video, we talked about reactivity. The two major types of elements on the periodic table are the metals. The metals chemical reactivity is going to decrease across the period but increase down the group. And the reason for that is the larger the atom is, the weaker the attraction between the nucleus and the electrons. So therefore the electrons are lost more easily, allowing the atom to become stable when it's interacting in a chemical reaction. Those are for the metals. Metals lose electrons to become positively charged. The nonmetals, on the other hand, increases across the period and decreases down the group. And again, the reason for that is as you go across the period, the atom becomes smaller and smaller because of the greater nuclear pull between the electrons and the nucleus. So the nonmetals are going to have a tendency to pull those electrons closer to it, attract electrons, and increasing their reactivity as they go across the period. So nonmetals gain electrons to take on a negative charge. So the first periodic property we're going to talk about in this part of the video, or this last video, is ionization energy. And ionization energy is the energy that's required to remove an electron from the electron cloud. Now the electrons are going to be those valence electrons. Let's take a look at an equation. You have element A, and A represents any element that you have on the periodic table. Element A needs energy in order to remove an electron, and the amount of energy that is needed is dependent on where that element is located on the periodic table. If it's located in an area where there's a weak attraction, then that element isn't going to need as much energy to remove an electron as if it has a stronger attraction to the nucleus. So here's what happens. We add some energy to the system. Element A is going to lose an electron, so we have our release of the electron right here. And then element A is going to take on a positive charge. So if it loses one electron, we'll have a positive 1 charge. Loses 2 electrons, we'll have a positive 2 charge. And for each electron the element loses, takes more and more energy. The amount of energy is going to increase. So let's take a look at this trend. As we go across the period, the trend is that the ionization energy is going to increase. Why is that? Because you have that stronger nuclear pull, more protons, stronger attraction between the electrons and the nucleus. So it's going to require more energy as we go across the period. Now, as we go down a group, the trend is for the ionization energy to decrease. And why is that? Because that atom, the atomic radius is getting bigger, so you have less nuclear pull, less attraction between the nucleus and the valence electrons. So it doesn't require as much energy as we go down a group. And here is a little schematic that we see across the period. As we see right here, the energy is going to increase. We require more energy to remove the electron, and as we go down the group, it's going to require less energy. Our last is called electronegativity, and that is the ability of an atom to attract or gain electrons. And by this time, you should probably figure out what that trend is going to be. Fluorine is the most electronegative atom with a value of 4.0. Scientists, chemists have arbitrarily given fluorine that number. The closer an atom is to fluorine, the greater the electronegativity is going to be. So it's rated on a scale of 0 to 4. Now, the trend in electronegativity is as we go across a period, the electronegativity is going to increase. Why? Because you have a greater nuclear charge, so therefore a stronger attraction to those electrons. And as we go down a group, the trend is that the electronegativity is going to decrease for the same reason as we saw with ionization energy. The atom becomes bigger, you have a weaker attraction between the nucleus and those valence electrons. And here we see a picture of that, and that is a summary and the end of Lesson 3, Part 2.